大家好，我是国立清华大学电机系黄衍介。那今天我要开始介绍电磁学2。电磁学2跟电磁学1一样，都有18个单元。那它的主要内容是跟波有关系，所以在有些学校，譬如说在清华大学电机系，我们已经把电磁学2多年前称作这个电磁波。那在第一个部分，我要介绍的就是波的基本概念，因为有了波的基本概念之后，这个学习会变得简单很多。So in this lecture, I'm going to start to talk about some wave phenomena. Just try to give you some physical pictures about a wave. And then the second part of the lecture is going to be related to equation called wave equation, 波动方程式. The solution of this wave equation is called wave function, 波函数。那这个波函数呢，是用来描述这些波的波动的现象等等。那the third part of this lecture is going to be introduction about sinusoidal wave, 弦波。弦波的话是在分析的时候呢很重要的一个工具，所以呢我们会做一个介绍。那最后在我们结束这个lecture 之前的话，我会介绍 wavefront。wavefront 是所有的波都有的东西，叫做波前。那最后有一点点的复习。所以在第一个小节里头，我们介绍 wave phenomena. So on this picture, I'm going to show you a string attached to a solid wall. Imagine that you pull this string really tight by your hand, and then the other end of the string is tied to a solid wall, and now you excite it with a little bit of the string. You're going to create a bump on this string, propagating in the forward direction. And when this bump reaches this end at the solid wall, this bump can be reflected back. So essentially, you provide some energy to this string, and this energy propagates toward this boundary. And when this energy reaches this boundary, this energy is reflected back. And in this process, you don't really propagate the material, you propagate the energy. So energy can be propagated without propagating material, and this is called a wave phenomenon, because in this process, you create a string wave in the forward direction, and then the wave is reflected back toward your hand. On this slide, I want to show you another wave phenomenon. This little creature is looking for food inside this water pump. And in this water pump, there could be some worm, and these birds would like to look for it and enjoy it. So when this bird is searching a worm or some food inside this water, the head of these birds start to vibrate, and this energy in fact can propagate on the surface of the water pump over some distance. So this is the excitation point of the water wave, and when this point is vibrating over time, you create ripples propagating on the surface of the water. And this energy can reach some distance away from this excitation source. And we call this as a water wave propagating due to the excitation of these birds. And then suppose you drop a little bit of the water onto the water surface, and you look carefully onto this system. Because this system is cylindrically symmetric, you start to see some spherical boundaries propagating away from the excitation point. And this boundary is well defined, forming circles on this water surface. And we call this the boundary wavefront of the water wave. And in some occasions, you can see the distance between two boundaries. And the distance is called the wavelength of this water wave. But the propagation direction of the wavefront is perpendicular to the boundary. So we can define a so-called wavefront vector that is perpendicular to the circular boundaries. And in between these two boundaries, we call this the spatial wavelength. But the whole wave is propagating, so you can also describe the distance between these two boundaries by time, and we call this the temporal period of the wave, denoted by t on this plot. If you do an inversion of this t, then this will be the frequency of the water wave. And for given a material like this water, the water wave is going to propagate at a constant speed, and this constant speed is equal to the wavelength divided by the temporal period, or the wavelength multiplying with the frequency of the wave. And this is water wave. Just like when we meet with a stranger, we like to describe this person with a name, so we use the shape of the wavefront to name a wave. For example, if you have a spherical wavefront for a wave, and then we'll call this a spherical wave. If you have a cylindrical wavefront for a wave, then we call this a cylindrical wave. And quite common that we model waves by using so-called plane wave, because for plane wave, the wavefront is a plane. So let me just summarize a few key points in this session. 刚开始的时候呢，我介绍了几个这个波的现象。那这个波呢，不管是在绳子上头的绳波，或者是水上头的水波，它都会传输能量。但是呢，这个绳子的分子、绳子的物质，或者是这个水的分子呢，并没有在流动。所以呢，一个波它会传播能量，但是呢，不会把这个物质呢从一个地方移到另外一个地方去。那这个波呢都有波前，那这个波前呢，经常就是用来描述一个波的这个现象。那波如果是一个稳定振动的这个波的话，它就有周期，这个时间的周期。那因为它在空间里头跑，所以呢，空间里头跑的这个周期呢，我们通称叫做波长。如果说我们把这个时间的周期把它取个导数的话，那这个波的频率就是这个时间周期的导数。如果说这个波是在一个均值的物质里头在传播的话，那它的速度就是一个定的速度。那这个定的速度呢，会等于它频率乘上它的波长。那这是第一个小节里头我要点出来的几个重点，谢谢。